Hello, this is Dr. Oz. In this video, I would like to show you how to conduct sensitivity analysis using Excel Solver. So this is the model that we developed for our network of two hubs, and we have some uh, three demand locations at Albany, Buffalo, New York City. And objective is to minimize the cost, and we try to decide how many loads of shipments should be sent from each of these origins to each of these destinations. And if you remember the problem, we have our capacity connecting those origins and destinations. And we have two constraints associated with our two hubs. And also we have um, Syracuse supply constraint, and we have three demand constraints for our demand locations. So again, if you run this model, data, solver, you can see the objective is the green cell, minimize, and decision variables yellow cells, and we put all the constraints here, and when we solve this problem, we can create sensitivity analysis by clicking on sensitivity and click OK. And that will create a sensitivity report that looks like this. And let's go over these numbers. So you can see these numbers right here. These are nine of them. These are decision variables that are calculated by the model, by the solver. So you can see those numbers are exactly the same as here. And also you can see the reduced cost means that if we get a value here, the reduced cost is zero because they're already part of my objective function calculation. However, for example, Albany shipment and New York City shipment has reduced cost of 50. What does that mean? Currently, the cost of shipping, this is the arc number 1, 2, 3, 4, 5. If you look at it, 5, which is Rochester, Albany. If I want to use this arc, I need to reduce the cost from 300 to at least at most 250, meaning that I need to decrease this cost by at least $50 so that I will start sending products from Rochester to Albany. Another example, for example, is the 8, arc number 8, which is Scranton to Albany. Current cost is 220, and those numbers are here as well, you can see. So if I want to start using that arc, I need to decrease the cost by at least $70. So these are again objective function coefficients. We talk about reduced cost, and then uh, allowable increase and allowable decrease is another important number as well. So let's take a look at allowable increase. 50, what does that mean? Current cost of the first arc is $400, which is again from Syracuse to Albany. So I can increase the cost by up to $50 from 400 to up to 450, and my solution, the yellow cells, won't change. However, the green cell, which is objective function number, will change because if I increase the cost, obviously the total cost green cell will go up. For example, if I increase by $5 from 400 to 405, basically 5 times 5, which is $25 of increase, should be observed for the objective function value. Even though decision variables won't change, but if I increase this, obviously my total cost, which is green cell, which is the objective, will increase. Decrease, for example, I could decrease this $400 by infinite amount pretty much, and still my solution won't change. The reason is that this is the capacity at this arc number 1. So if you take a look at the capacities, it's at 6. So even if this was free or if I make infinite money, still I cannot ship more than 6 products. Let's take a look at another example of these allowable increase decrease values. So for example here, I could increase this cost 300, which is arc number 1, 2, 3, 4, 5 by infinity. So arc number 5 is Rochester, Albany. I can increase this cost from 300 to pretty much infinity or any number in between 300 and infinity. Still, I will not that will not change my solution. The reason is that if this arc doesn't make any sense at 300 cost level, why would it make sense if I increase the cost? Okay, that's what this number means. However, here, if I decrease this cost, $300 arc cost per shipment, at least by $50, then this solution will change. I don't know what the new solution will be, but it will change. Probably I will start sending products on this arc. So let's take a look at the second table. And here you can see that these are the left-hand side values of my constraints. And here are my right-hand side values of my constraints. And you can see that, for example, here, my left-hand side of this arc capacity constraint is zero. Shadow price is zero. What does that mean? That means that current capacity, I can send up to 6 units, and currently I'm only sending 5 units. If I increase the right-hand side value by any amount up to infinity, still that will not change my cost, which is objective function at all. Why? Because this is not a binding constraint. Binding constraint or bottleneck constraint means that the left-hand side values are equal to right-hand side values. So in this case, it's not. So that means there's idle capacity. That means that if I increase the capacity, that won't change anything to my objective function because I have already idle capacity. However, if I decrease this one by more than 1 unit, then things will change. The shadow price won't be zero anymore. It will change. Let's do another example. For example, right here, currently Rochester Hub as the right-hand side value is 0, left-hand side value is 1. So that means that if I can increase this right-hand side value by actually allowable increase 0, so that doesn't really make any sense. But if I decrease it by 1, that means that this cost, objective function cost, will go down by $150. Let's do another example. For example, here we have demand Albany. So current right-hand side value demand is 5. Current left-hand side is 5 as well. This is a binding constraint since the right and left-hand side is equal. So if I increase this cost by 1 unit, normally my cost should increase, overall cost should increase by 400. However, my allowable increase is only 0. That means that that's not gonna work. That doesn't make any sense because allowable increase is 0. If I increase by 1, that means that 1 is greater than 0. That means that this doesn't apply. However, I can think about opposite. So if I decrease this by right-hand side value by 1 unit, then I can think this as a negative, then my cost will decrease by $400 up to 5 units. For example, if the demand decrease from 5 to, let's say, 2 units, which means 3 units of deduction, that means that 3 times 400, $1,200 decrease in total cost. I hope this helps you, and until next video, enjoy business analytics.